Hello everyone, welcome to my YouTube channel. Thank you for watching. I would like to take up various topics on diagnosis, troubleshooting and repair, and show you examples of how I proceed. I also have videos that explain how some components or assemblies work in the vehicle. I hope you like it and that you can use some of my tips and explanations. Have fun! Today I am dealing with a problem on a Volkswagen Polo Type 6OR. The airbag and ABS indicator lights are illuminated on this vehicle. First of all, this much about the fault lights coming on. My experience shows that the cause of some electrical and electronic faults can come from an inadequate power supply. After picking up the vehicle from a friend, I noticed that the time was not displayed correctly. When I asked, I was told that the battery was discharged and that the vehicle had been jump-started a few days ago. After connecting the diagnostic tester, I noticed that despite a long drive to the workshop, the battery voltage was only exactly 12 volt. I need a sufficient power supply for the diagnosis. I have therefore connected a charger. The supply voltage is now displayed as 13.7 volts in the diagnostic tester. I then read out the fault memory of all systems. I am shown that errors are stored in both the brake control unit and the airbag control unit. The rest is fine. No error. First, I will read out the fault memory entry in the airbag control unit. The fault memory entry in the airbag control unit is, you see the number, deactivation switch airbag passenger side signal, implausible. The fault memory entry in the ABS ESP brake control unit is, you see the number access immobilizer control unit, signal implausible. To start the diagnosis, I check the battery. To do this, I take the Bosch tester and go to the battery starter current program in the vehicle system analysis. There I have to enter the cold test current value of the battery and the test standard for the cold test current in the tester, CCA and CCA standard. This information can be found on the vehicle's battery. The cold test current of this battery is 470 amps, and the standard for this battery is EN. There are other standards such as DIN, SAE, and IEC. The difference lies in the sometimes different test procedures for determining the cold current. I now enter the values in the diagnostic tester. I enter the following data: CCA 470 ampere and CCA standard EN. The connection instructions for the tester can be found in the help program. Under standard information and connection instructions, you will find which connection cables are required for the diagnostic tester and how they are to be connected. The instructions must be followed exactly, otherwise an incorrect result will be obtained. To test the battery and not the connected charger, the latter must be disconnected beforehand. To connect the required measuring cable, use the sockets located on the battery connection cable of the tester. Channel 1 of the tester is used for the voltage measurement. The connection is shown here on the earth cable, or minus cable. I use the sockets on the back of the battery connection cable. This ensures a good and secure connection of the connection cables. To measure the starter current, I need the 1000 amp measuring clamp of the tester. I need to place this over the main power cable from the battery to the starter motor. The arrow on the clamp meter must point in the direction of the battery. If the clamp meter is connected the other way around, the tester will not calculate any values. It is stated here in the connection instructions. As the newer vehicles require very little time for the engine to start, the engine must be prevented from starting. There are different options depending on the vehicle. On this vehicle, the easiest way I can see is to loosen the 3 plug connections on the injection valves. Of course, the engine will not run without fuel. The battery voltage is currently 12.3 volts. However, for a meaningful measurement, the battery voltage must be at least 12.5 volts at the start of the test. I therefore connect the battery charger again for a while. Now I have to wait a while until the battery has a voltage above 12.5 volts and then disconnect the charger again. Now it should be sufficient. The battery voltage is 12.6 volts. Unfortunately, the voltage drops very quickly. I will now do the test with 12.4 volts. I'm going to start the test right now. To do this, I need to operate the vehicle starter for a few seconds. For this vehicle, This means putting the ignition key in the start position. The software then freezes the image automatically without me having to do anything on the tester. If I connect the amperage clamp the wrong way around, the image does not stop automatically. On the left in the picture, the scale for the voltage in blue, and on the right for the current in red. The internal resistance of the battery of 9.4 milliohms determined by the software is displayed at the top. The maximum battery voltage of 12.4 volts, the minimum battery voltage of 8.9 volts. The maximum internal resistance may be 9.5 milliohms. The current consumption was 376 amperes. The minus and the minimum current consumption are somewhat confusing. This is due to the tester's software. The current consumption can be observed in the oscilloscope image. At the time of starting, the current is at its highest, as the internal resistance of the starter motor is almost a short circuit at standstill. As the starter motor turns, the current consumption decreases. The shaft movement is caused by the difference in current consumption, as more current is required in the respective cylinders during compression. The battery voltage drops to the minimum value during the so-called breakaway torque of the starter. You can find information on the vehicle battery in the Help menu under Operating Instructions. The test conditions for this test are also listed there. There is also a comparison table of the respective cold test currents. We can now compare our battery in this table. We have a 470A battery. However, the table only lists one with 480 amps. Let's use this for comparison. The target value of the internal resistance for a very good battery is up to 6.4 milliohms. The battery would be conditionally cold startable at a value between 8.0 and 9.1 milliohms. Above 9.5 milliohms, the battery is no longer cold startable. In our measurement, the value of 9.4 milliohms was highlighted in yellow, which already indicates that the battery is no longer particularly good. Here is the result again. Internal resistance of the battery 9.4 milliohms. This battery is only conditionally cold startable. In fact, the battery is already on the verge of not being cold startable. A new battery should therefore be installed in any case. To check why the battery is no longer okay, I will check the onboard electrical system. It does not make sense to just install a new battery, as a defective or weak battery may be the cause of a fault in the power supply system. This could then also be the cause of the faults in the airbag and brake system. For me, this now means that I will first take care of the vehicle's power supply before carrying out further diagnostics for the airbag and brake system. After charging the battery again for a few hours, I carried out the test again. The result now shows a slightly better internal resistance of 7.9 milliohms. I will charge the battery overnight and see tomorrow if the internal resistance improves. Next up, I will check the voltage drop in the positive and negative leads of the starter main leads. This test is carried out during the starting process in order to be able to make a statement about the condition of these cables. This is an indirect resistance test of the cables via the voltage drop and the current flow in the cable. I now test the voltage drop in the ground cable from the battery to the engine block. I choose the universal oscilloscope from Bosch Volkswagen Analyze for this test. You can see the settings for the scale on the screen. The stop button on the tester must now be pressed, as the image does not freeze itself. The result shows a current consumption of approximately 500 amps and a voltage drop of 2.3 volts. This results in a resistance of 0.0046 ohms for the earth lead. Now I check the positive lead. The measurement shows a voltage drop of 1.1 volts in the positive lead. The voltage display goes down because the connection cables are connected the other way around. However, this does not affect the result. The result is for the starter main lead that goes directly from the battery positive terminal to the starter. Calculated, this gives a resistance of 0.0022 ohm. As the ground cable consists of two sections, I carry out two further measurements. I now measure the voltage drop in the ground wire between the body and the engine. Here you can see where I have connected the test leads. We have a voltage drop of 2.2 volts in this line. Then there is the ground wire that leads from the battery to the body. Here I measure a voltage drop of 0.2 volts. However, this cannot be seen here in the video. After I have connected a jumper cable between the body and the engine, the voltage drop in the entire ground line is reduced to 1.25 volts. I also took a measurement of the voltage drop in the ground line from the body to the engine when the consumers are switched on to check what voltage is being supplied by the alternator, or rather, how much charging voltage is being lost. This was 0.6 volts. Fortunately, this cannot be seen in the video. As a result, the battery was never properly charged. The voltage at the battery was never higher than 13 volts when fully charged. After I replaced the earth cable between the body and the engine and cleaned the connections, this voltage rises to 13.6 volts when the engine is idling, as you can see here. The alternator delivers a current of between 55 and 80 amps. It is therefore fully loaded. So I replaced a ground wire in this vehicle and cleaned the connections of the two ground wires. Since then, the car has been driven without the fault lights coming on again. The cause was therefore a faulty power supply. The battery has also recovered. A new one did not have to be fitted. Faults like this, i.e. fault lights from different systems lighting up, often occur during the starting process as the battery voltage drops too much due to such wiring problems. Therefore, my experience shows that a problem in the power supply is often the cause of unclear fault memory entries. Thank you very much for watching my video. I am happy about likes and followers. Also take a look at Autofixxpro.com. Do you have any solved problems? Post them there. It costs nothing. Try it out. I would be very pleased.